Hi friends, welcome back on the another video of FMT, that is featureization and model tuning. So today we will see upsampling and downsampling. Like we have heard many time we do upsampling with our data, many time we do downsample with our data, right? So today we will see the case study on that. Now let's start by importing our necessary library, that is pandas logistic regression from sklearn linear model, right? Then we are importing plotting libraries like plt pyplot. Then we are importing seaborn for statistical plot, seaborn as SNS. Now let us break the x and y data frame into training set and test set. For this we will use sklearn packages data splitting function, which is based on random function, right? So from sklearn.model selection, import train test split, importing numpy as np. Now calculate accuracy measure and confusion matrix. So from sklearn, import matrices. From sklearn.matrices, we have import recall score, right? From imb learn dot oversampling from smooth. So since it is a data file with no header, we will supply the column name which have been obtained from the above url. So create a python list of column name called names, right? Columns equals to preg plus press skin test mass, right? Prediction age class. Now load the file from local directory using pd.read csv, which is a special from form of a read table. Now while reading the data, supply the column list. So pima df equals to pd.read csv, right? So this is the data that we are reading. Name equals to columns. So pima df dot head, so head of 50. So here you can see that preg plus press skin. So all these for our the data set that is containing, right? So you can see here. Now let us check whether any of the column has any value other than numeric. Data is not corrupted, such as a question mark instead of a number. So we used np.isReal, a numpy function which checks each columns for each rows and return a bool array, so where true if input element is real. So now apply map is panda data frame function that applies the np.isReal function, right? And that is in column wise. Now following line selects those rows which have some non-numeric values in any of the column, hence that is the symbol that we have passing. So pima df, right? This is the symbol tilde, pima df dot apply map np dot isReal all equals to 1, right? So these have some numeric values in any of these column. So we are checking that, but we are getting nothing. Now replace the missing values in pima df with the median value. Note, we do not need to specify the column names. Every column's missing value is replaced with that column's median respectively. So pima df equals to pima df dot fill na, pima df dot median, right? And the pima df that we are calling now pima df dot describe dot transpose. So here we are transposing it. Now count mean, standard deviation, mean and interquartile ranges and max that we are passing. Now let us look at the target column, which is class, to understand how the data is distributed amongst the various values. So pima df dot group by, so class dot count we are calling again. So most are not diabetic, the ratio is almost 1:2 in favor of class 0. So the model ability to predict class 0 will be better than predicting classes, right? So this is the data that we have. Now let us do a correlation analysis among the different dimension and also each dimension with the dependent dimensions, right? So this is done using scatter matrix function, which creates a dashboard reflecting useful information about the dimension. The result can be stored as a .png file and open in, say, paint to get a larger view. So pima df attribute equals to pima df dot ilog. So this is the commented that so this is nothing, right? Now we are using peer plot, right? So we are using peer plot for our pima df, right? So this is the plot that we have now. Let's continue. So then we have data for all the attribute are skewed, right? So here we can see, and especially for the variable test. So the mean for the test is 80 rounded, while the median is 30.5, which clearly indicate an extreme long tail on the right. So now attribute which looks normally distributed, like all these attributes that we have, and some of the attribute looks like they may have an exponential distribution, right? All these attribute. So age should probably have a normal distribution, and the constraint on the data collection may have skewed the distribution, right? Now there is no obvious relationship between age and constant onset of diabetes. So there is no obvious relationship between PADI function and onset of diabetes. So you can go through with this peer plot and you can get the same thing. Now let's move forward. So we are defining an array, right, of pima df dot values x. We are selecting all rows and first 8 columns, right, which are the attributes. So this is not, but 0 to 6 column. Now similarly for y, right, and we are defining test size as 30%. Now seed we are giving 7. So seed is nothing but this is a random number seeding for repeatedly of the code, right? Now x train, y train, x test, y test. So we are passing print test split into x, y, and test size is test size, random state equals to seed, again type of x train, right? So let's do smooth to upsample smaller class. So basically small is the term for sampling, right, data. Now before sampling, count of label 1, format sum y train equals to 1. Now before upsampling, counts of label 0 dot format sum y train equals to 0, right here. Now sm equals to smooth, sampling strategy 1, k neighbors equals to 5, random state equals to 1. So synthetic minority over sampling technique. Now x train res and y train res equals to sm dot fit resemble x train y train dot revel, right? Print, we are printing after upsampling counts of label 1, right? So this is for format of y train where res equals to 1. After upsampling, right, count equals to, if 0, counts of labels is 0, right? Similarly for upsampling, if the shape of x train and shape of train y. So before upsampling, count of label is 1, so count of label is 1, that is for 184. But before upsampling, if count of label is 0, then we have 353. Similarly after upsampling, you can see for 1 it is 353 and for 0 it is 353, which is correct. Now after upsampling the shape, we have 706 by 7, and again after upsampling the shape that we have is 706. So on so forth. If we fit the model on original data, that is before upsampling, and we just doing model dot score, right, to get that score finally. So we are getting 77% here. Similarly we are printing the classification report here, right, for precision recall. And if we talk about the recall, let's say for 0 it is 90% and for 1 it is 55%. Again we are doing model dot fit on x train res, y train res, y prediction, that predicting values, right? Now model dot score x test, y test. So print model score here, print matrix dot confusion matrix, y test, y prediction, print matrix dot classification report, y test and y prediction. So here we have the accuracy of 76%. Now downsampling the larger class, so non-diabetes indices. So pima df class equals to 0 dot index. So get the record number of non-diab cases. So no diab, now length of pima df class equals to 0. That means how many non-diab cases are here. So it will basically return that non-diab. So we have 500. Now if we check for diabetic cases, so we have 268 out of 268 diabetic cases, whereas 500 non-diabetic cases. Now random indices is what we are doing here. We are calling the random dot choice here, and non-diab indices, no diab minus 200. So basically we are randomly picking 200 non-diabetic indices, right, and where replace equals to false. Similarly downsample indices, so here we are basically concatenating, that means combining all these 200 picked non-diab indexes with the diabetes indexes, right. So let's move forward. Here we are extracting all these record for diabetic and non-diabetic to create a new sample here, right. If we get the shape here, and finally we are looking at the class distribution after downsample. So for 0 you can see for every attribute, and this is for 1 for every attribute. Now array equals to pima df downsample values, right. So x equals to array, so select all rows and first 8 column which are all the attribute. Y array, we are select all rows and the 8th column which is the classification, yes no for the diabetic and non-diabetic attributes. Test size, again 70 by 30 ratio, seed equals to 7, and again doing the same thing that we have done last time. Now we are checking this time as for downsampling, right. So this is we train for a downsample. Okay, so here you can see after downsampling the shape of x train is 397 by 7, and after downsampling the shape of x test is 171 by 7. So fit the model on 30%. so here model equals to logistic regression, model dot fit x train y train, y predicted, we are model dot predict x test, and model score model dot score x test y test. So printing model score, right, printing matrix dot confusion matrix y test y prediction. Now printing matrix dot classification report y test and y predict. So here you can see we are getting the accuracy this time as 70%. So now we have precision, recall, F1 score and support, everything is here, right. So now if we talk about IMB learn for random undersampling, so we are getting the random undersampler from undersample which is in IMB learn. Now RUS random under sampler, so return indices is equals to true, XRUS y RUS ID RUS. So all these we are getting to fit our resample of x train y train. If we print that y RUS, so here you can see we are getting all that for 0, similarly for 1. Now if we get that shape, so we have 368 rows here basically. Now IMB learn random oversampling, so from IMB learn dot oversample import random sampler, ROS equals to random oversampler, we have XROS YROS, so ROS dot fit resemble x train y train, so YROS, so all that you can see here, right. Now we have YROS dot shape 706, so XROS dot shape we have 706 in by 7, deleting nearest majority neighbors, right, Tom link. So here we are importing Tom link from undersampling. So these are different technique we can do for undersampling and upsampling and downsampling. Now Tom links return indices true, ratio equals to majority. So again XTL, so all these ID we are basically removing TL dot fit resembling this, right. So what it is saying basically the IDTL is removed and instances of majority classes. So if we get the new shape of YTL dot shape, so it is 497. If we get XTL dot shape, it is 497 by 7. Now upsampling followed by downsampling. So how we can achieve that? Again we will simply use smooth to mac, right. So SMT equals to smooth to mac, so ratio equals to auto, so x SMT y SMT, SMT dot fit resemble, so x train y train that we are getting. So x SMT dot shape if we call that, so 664 by 7, right. Now cluster based undersampling, how we can do that? So from IMB learn dot undersampling import cluster centroid, okay, CC equals to cluster samploid, so XCC YCC CC dot fit resample x train y train. So XCC dot shape, so this is 368 by 7, and YCC we can see that 0 and then 1. So yeah, this was all about for upsampling and downsampling. So I did not go too much in the theory part, but yeah, the practical knowledge that we have was to how to use all these algorithms, right? So hope you got a fair idea that how we can impose all these algorithm for upsampling and downsampling with our data. So yeah friend, this was all about today. Hope that you like the video, right? And stay tuned. All the best. Let's meet in the next video. Have a good time.